Today, let's take a look at a real-world double replacement reaction. So what I have here is lead 2 nitrate to be exact, and I have here potassium iodide. Now these are both ionic compounds. So what I want to show you first of all is that I just have beakers of simple water here, but I'm going to take some of this lead 2 nitrate, and I'm going to dissolve it into the water. So it's a powder, but as I mix it up in the water, you're going to see that it's going to eventually dissolve. The water will be a little bit cloudy, but it will dissolve. Now, when this happens, we say that this compound is in an aqueous state. So when we talk about that with double replacements, what does aqueous mean? It means that it was a solid powder, but now dissolved in water. Okay? So there we go. I have now my aqueous solution of lead 2 nitrate. I also want to take my potassium iodide and do the same. So I have some water right here. I'm going to put some of my powder in. And I'm going to stir that up and dissolve that into the water. Now that that's dissolved in the water, I have 2 aqueous solutions of 2 different compounds. Now, let's take a look at the balanced equation, or I should say, now let's take a look at the equation of these 2 coming together, and if their cation swap and a double replacement works out, what product can we predict? Let's look at that. So the reaction we're about to start here is really between 2 aqueous compounds, lead 2 nitrate and potassium iodide. Since these are both aqueous compounds and brought together, there's a potential for a double replacement reaction, which means that potassium could now swap out, leave iodide, and occasionally combine with nitrate. So the question is, when potassium nitrate is formed, will that create another aqueous compound or will that be a solid? But also lead is going to now combine with iodide. So lead 2 iodide is going to be the new compound. The question, of course, is, will lead 2 iodide form a solid or an aqueous compound? Well, let's take a look using our solubility chart. Let me change my color here really quick. Potassium nitrate. Potassium's right here. Nitrate's right here. So when those 2 come together, it is an S, and S stands for soluble. So for potassium nitrate, this is going to be aqueous. How about lead 2 iodide? So here's lead, here's iodide. Bring those together, and it is an I for insoluble. So it looks like if we mix these 2 together, we should create a solid compound called lead 2 iodide. So if we end up writing that all out, let's start thinking about what this would look like as a chemical equation. So lead 2 nitrate. Lead is going to be Pb2 plus. Nitrate is going to be NO3 minus 1. For potassium iodide, potassium is K with a positive 1 charge. Iodide has a minus 1 charge. And I'm getting those just from my chart up here that I was using earlier. Next then is my potassium nitrate. Potassium has a positive 1 charge. Nitrate is a minus 1 charge. And then there's lead 2 iodide. Lead is 2 plus, that's why it's called lead 2, and iodide is minus 1. All right, so we can now put those together as ionic compounds, and we can finally see exactly what is going to form. So here we go. Lead is 2 plus, so I'm going to need 2 nitrates to balance that out. Remember that that is aqueous, we already know that. Next up is the potassium iodide. That's just 1 of each because they're plus 1 and minus 1. And that's aqueous. We know next is the potassium nitrate, which we already figured out was aqueous. That becomes KNO3 because +1 and -1 cancel out. That's aqueous. And then we have our last one here, 2+ lead, -1 iodide. So I'm going to need 2 iodides for every 1 lead, and that's going to be the solid. Now that I have that, I just need to make sure I balance this out. I have 2 nitrates, so 2 nitrates, but that's going to give me 2 potassiums, so 2 potassiums right there. But that'll give me 2 iodides, which I already have, and lead. So I think I'm balanced 1, 2, 2, 1. But in the end, when we mix these together, we'll be looking for this solid lead to iodide. That's the thing to keep our eyes on. So let's go back to the demo and see when we mix these 2 aqueous solutions together, will we get this new solid compound, and what will it look like? Now that we've predicted what product we should have, let's make sure it works. Let's mix them together and see what happens. Well, I don't know about you, but that looks like a reaction, absolutely. So why this liquid is yellow is actually there is a yellow solid that is now suspended in the liquid. And if we took filter paper and we strained out this liquid, you would actually end up with a yellow powder. And that yellow powder is, of course, that final product we predicted in our equation. All right? So once we had that double replacement reaction take place, we had, of course, our lead iodide show up as a solid, while the other compound, potassium nitrate, stayed aqueous and is just dissolved in the water. But there you have it, a double replacement reaction, live and living color, demonstrating you the difference between what aqueous is and, of course, what a new created solid is as a product in a double replacement reaction. Take care, science fam.